Welcome to The Explainer. Today, we're diving into something pretty wild, a breakthrough that's teaching artificial intelligence how to have a private inner voice, an internal monologue, just like we do.
But hey, before we get into all the tech, let's start with a simple question. Just think for a second about the last time you had a really tough problem to solve. How did you actually figure it out?
Well, if you're anything like most of us, you use this incredibly powerful tool called an internal monologue. It's that quiet little debate you have in your own head, right? Where you weigh the options, challenge your own assumptions, and kind of shape your plan until you land on the best way forward. Now, here's the thing. For the longest time, AI just couldn't do that. To solve a complex problem, it had to think out loud. It had to rely on this slow, really expensive back-and-forth conversation with other systems to check its work. It was kind of like a student asking the teacher, "Is this right? How about this step?" after every single calculation. I mean, it gets the job done, but it's incredibly inefficient. And that right there is the core difference. The old way was this clunky, external conversation, super slow and really costly when you think about the computing resources it eats up. The new way, the INOT way, is a private, internal monologue that all happens inside the AI itself. And as you can guess, that's way faster and a whole lot more efficient.
So, this brings us to the solution, a really clever new framework called Introspection of Thought, or INOT for short.
Okay, so the really crucial idea here is that INOT takes that entire messy, multi-step debate and moves it inside the AI model. It's not a back and forth anymore. Nope, it's a deep, reflective process that happens all in one go, before it even gives you a final answer.
So you're probably wondering, how in the world does this actually work? Well, the best way to think about it is that INOT gives the AI a script for a little internal play, complete with different characters and even stage directions.
The foundation for this whole script is XML. Now, don't worry about the technical details. Just think of XML as the script binder. It's just a super clear, structured way to hold all the instructions so the AI knows exactly what it's supposed to do. No confusion. And tucked inside that binder is the real magic ingredient, something they call prompt code. Now, this isn't actual computer code. It's this really cool hybrid language. It uses commands that look a lot like Python to give it logical direction, but it mixes that with just plain natural language to give the AI all the rich context it needs to really understand the task. This prompt code then guides the AI through this really structured 5-step debate. So just picture two little virtual debaters inside the AI's head. First, they each present their solution. Then, they critique each other's work, actively trying to find flaws. It's a process called self-denial. After that, they rebut the critiques, defend their logic, and then adjust their answers based on that feedback. And they just keep repeating this whole cycle over and over until they finally agree on the best possible answer. Okay, so what's the actual payoff? What happens when you teach an AI to think this way? Well, the results are pretty transformative. Let's take a look at the numbers.
First and foremost, let's talk cost. By getting rid of all that external back and forth, INOT massively slashes the operational cost. This is measured in something called tokens. You can just think of them as the little pieces of data the AI has to process. And we are talking about an average cost reduction of over 58%. That's a huge saving in computing power.
And it's not just cheaper, it's also smarter. That whole internal debate process acts like a powerful, built-in error-checking system. By forcing the AI to challenge its own logic, it catches mistakes before they ever see the light of day. This leads to a really significant accuracy boost of nearly 8% on tough stuff like math and coding problems.
And what's really cool is that this isn't some one-trick pony. The IONIT framework is incredibly versatile. Yeah, it works for your standard text-based problems, but it's also proven to be super effective for complex visual tasks, like having an AI analyze a photo and reason about what's actually happening in it.
Okay, so let's zoom out and look at the bigger picture here. This kind of internal thinking, it's not just another upgrade, it is a genuine game changer for the future of artificial intelligence. The source material for this explainer puts it perfectly. This ability to introspect, to think, to reflect, and to self-correct, it isn't just a neat feature. It's an absolutely crucial building block for developing the next generation of more advanced and truly autonomous AI agents. So the really big takeaway here isn't just that this makes AI cheaper or a little more accurate. No, it's that it fundamentally changes how it solves problems. It makes it more robust, more reflective. And that leaves us with one final kind of mind-bending question to think about.
If an AI can now truly think to itself, what on earth is it gonna think of next?